Hello everyone, in this video we are doing an introduction to fractions in order to help set us up for adding, subtracting, multiplying, and dividing fractions. So before we jump in, I want you to think about this riddle. So if Alex ate 3 slices of pizza and Susie ate 2 slices of pizza, but Susie ate more pizza than Alex, how is that possible? So I want you to think about that for a minute. How is it possible that Susie ate more pizza than Alex if she only ate 2 slices, but Alex ate 3 slices? Now, in order for that to happen, the slices that Susie ate would have to be bigger than the slices that Alex ate. So even though he ate a different number of slices, if his slices were smaller, then altogether he ate less pizza than Susie's. So that tells us that the size of the piece is important. If the pieces are not the same size, it is hard to compare the actual amount of pizza that they each ate. So I want you to keep that in mind as we go through the lesson today. So jumping into fractions, I want you to think about these 2 questions. So you don't actually have to solve them out. I just want you to think about how you would go about solving these 2. So if I asked you to put the following fractions in order from smallest to biggest, you have 2 questions here, question 1 and question 2. So I want you to look at those 2 questions and think about how you would order them. Okay. Now, if I said to you that I would give you $100 if you got the answer correct, but if you got the answer wrong, you had to give me $100. Which of these questions would you feel more confident in answering? A lot of you are going to say question number 2. I'm going to submit question number 2. Why is that? It's probably because they're all out of 6. And again, if we think back to the Susie and Alex riddle, we know that these pizzas are all the same size. These slices are all the same size because the pizza has been cut into 6 slices. So it's easier to compare which one's bigger and which one's smaller. In this one, this pizza has been cut in half, but this pizza has been cut into 12 pieces, and this pizza has been cut into 6 pieces, and this pizza has been cut into 4 pieces. So it's very hard to determine right off the bat which one's bigger and which one's smaller because their slices are all different sizes. So as we go forward working with fractions, I want you to keep in mind that it can be really hard to compare fractions when their bottom number, the denominator, is not the same. When the denominators are the same, we know that the pieces or slices are the same size. So it becomes easier to compare them, add them, subtract them, and so on. So our goals for this video is to be able to find equivalent fractions and common denominators. So making the bottom number the same to make it easier to compare fractions. We're also going to look at simplifying fractions and converting between mixed numbers and improper fractions. And this will set you up for all the skills you need to know in order to be able to add, subtract, multiply, and divide fractions. So let's start with equivalent fractions. Equivalent fractions are fractions that have different numerators and denominators, but represent the same value. So if you look at this picture here from Q Math, we have 1/2. So the pizza has been cut into 2 pieces and we have 1 of those. Here I have 2/4, 3/6, and 4/8. But if you look at the amount of orange, it's the same in each of these pictures. That means that these fractions are equivalent because even though their top and bottom numbers are different, they represent the same total amount of the circle. So again, let's look at these 4 pictures here. How many of the sections are blue in each of these pictures? I have 1, 2, 4, and 8. How many equal sections is each square cut into? So this first one's cut into 2, the second one's cut into 4, 8, and 16. So if I wanted to write a fraction to represent the amount of blue, I would say that there's half, 2 quarters, 4 eighths, and 8 sixteenths. Are these fractions equal? Yes, because they have the same amount of blue. If you look at the amount of blue in each of these squares or rectangles, you would say that they represent the same amount of blue in total. But they have different top and bottom numbers, meaning that these fractions are equivalent. So how do we go from one fraction to the next? If we're not looking at the picture, we're looking at the fraction itself. Mathematically, what do I have to do to go from half to 2 quarters? I multiply by 2. And to go from 2 quarters to 4 eighths, I multiply by 2. And 4 eighths to 8 sixteenths, I multiply by 2. So to find an equivalent fraction, you multiply the top and the bottom by the same number. So notice that to get from 2 to 4, I multiply by 2. But to get from 1 to 2, I also multiply by 2. If I just multiply the bottom, then this would end up as 1 quarter, which doesn't represent how much blue I have in this photo. So that is probably the most common error people make when they do this. Make sure that whatever you do to the bottom number, you have to do to the top number as well, or you're changing the amount of blue that's in the photo. So let's make the following fractions equivalent. I have the fraction 2/5, and I want to put it as a fraction out of 10. Well, I need to look at what I do to go from 5 to 10, and I multiply by 2. So to get my top number, I'm going to multiply 2 by 2 as well, and I get 4/10. So 2/5 and 4/10 represent the same amount of blue, and so they are equivalent. Okay, I want you to try these next 2. Pause the video, try them out, and start it up again when you're ready. Okay, so to go from 5 to 30, I'm going to multiply by 6, which means I need to multiply the top by 6 as well, and I get 12. And for our next one, we're actually given the top number. So to get from 2 to 8, I'm going to multiply by 4. So I'm going to do that to the bottom as well, and I get 20. Okay, I want you to try these. Can you convert each of these to fractions over 16? Pause the video, try them out, and start it up again when you're ready. Okay, so to get from 4 to 16, I multiply by 4. So I'm going to multiply the top by 4 as well, and I get 4/16. To go from 8 to 16, we multiply by 2. So I'm going to multiply the top by 2 as well, and I get 6/16. And 2 to get to 16 is times 8, so I'm going to multiply the top by 8 as well, and I get 8/16. Excellent. So let's look at how we find common denominators. So common denominators happen when the bottom number is the same. So we can actually use equivalent fractions in order to make common denominators. And again, remember, we like common denominators because they help us compare fractions easier. So for example, which fraction is bigger? Looking at 1/3 or 4/6, it can be hard right off the bat to know which one's bigger, which one's smaller, because their bottom numbers are different. we want to make the bottom numbers the same. So we're going to find the lowest common multiple of 3 and 6. There's a couple different ways you can do this. You can either write lists of 3 and 6 and find the smallest number, or you can use a prime factor tree. We're just going to write a list. So if I count up by 3s and I count up by 6, I see that 6 is the first number that's in both lists. So what I can do is write 1/3 and 4/6 as fractions out of 6 in order to compare them. Okay. So to get from 3 to 6, I multiply by 2. So I'm going to multiply the top by 2 as well. And I get 2/6. And 4/6 is already out of 6, so we can just leave it as 4/6. So now looking at these two numbers, 2/6 and 4/6, we can see that 4/6 is bigger. So let's try this one. 2/3 or 3/4, which one is bigger? So I'm first going to find the lowest common multiple of 3 and 4. So I'm going to write out the multiples of 3, write out the multiples of 4, and I see that 12 is the first number in both lists. So I'm going to write 2/3 and 3/4 both as fractions out of 12. I'm going to give them a common denominator so that I can compare them easier. So to get from 3 to 12, I'm multiplying by 4. 2 times 4 is 8. To get from 4 to 12, I multiply by 3. 3 times 3 is 9. So I get 8/12 and 9/12, which tells me that this is bigger. 9/12 is bigger than 8/12, which means 3/4 is bigger than 2/3. Okay, I want you to try these ones. I want you to circle which one is bigger. And you're going to make them common denominators to help you compare them. So pause the video, try them out, and start it up again when you're ready. Okay, so looking at these, a common denominator here would be 16. So I'm going to make 5/8 into a fraction out of 16, and I see that 5/8 is bigger. For the second one, a common denominator there is 32, and I see that 28 out of 32 is bigger. And for the bottom one, a common denominator is 64, and when I make them common denominators, I see that 3/16 is bigger. Okay, let's look at simplifying fractions. Now, simplifying fractions uses a very similar process to how we find equivalent fractions, except we're going down. We want to find an equivalent fraction that is the smallest form or the simplest form of that number. So instead of multiplying up, I'm going to divide the numbers down in order to find the simplest form. Okay, now again, remember, just like we do with equivalent fractions and common denominators, whatever we do to the bottom, we have to do to the top. Okay, so if I want to simplify these fractions, I'm going to simplify 9/12. I'm looking at the number 9 and the number 12, and I'm thinking what number can be divided into both of those. Okay, so what number goes into 9 and 12? And I see that 3 does. So I'm going to divide the top and bottom numbers by 3, and I get 3/4. I'm then going to see, okay, can 3/4 go down any smaller? No, they can't. There's no number that goes into 3 and 4 except for 1. Okay. Now, if you can't find the biggest number that goes into it, you might have to do more than one step. You just want to keep going until you get to a number like 3/4 that can't go down any smaller. Okay, it's okay if it takes you more steps as long as you keep going down until you can't go down any further. So for the fraction 8/32, I can see that 8 goes into both of those. So I'm going to divide by 8 and I get 1/4. But maybe you saw 4 or 2. So if you saw 2 here, you would go down to 4/16. And then you would see that that can be divided by 4 and get to 1/4. So you may have more than one jump here. It's fine as long as you keep going down until you can't go down any further. Okay, and so 42/64, I see immediately 2. I'm like, okay, I know 2 can go into both of those numbers, so let's just start there. And I get to 21 out of 32. Then I'm looking at 21 and 32, and I don't see any number that can go down or into both of those, so it can't go any further. So I just leave it at 21 out of 32. Okay, so I want you to try these 3. You're going to simplify them into their simplest form. So pause the video, try it out, and start it up again when you're ready. Okay, so 10/16 can go down to 5/8 by dividing by 2. 24 out of 32 can go down to 3/4 by dividing by 8. And 12 out of 64 can go down to 3/16 by dividing by 4. Okay, lastly, let's look at improper fractions and mixed numbers. So an improper fraction is where the numerator is greater than the denominator, or the top number is bigger than the bottom number. So if I want to represent the amount of green here using an improper fraction, I would say that I have 1, 2, 3, 4, 5, 6, 7 pieces out of a whole that's cut into 4. So I would say 7/4. Again, the 4 represents how many pieces it takes to make one whole. So it's not out of 8. Okay? It doesn't take 8 to make one whole. It takes 4 to make one whole. So I would say 4, and I have 7 pieces, so 7 out of 4. A mixed number is where you have a whole number in front and then a fraction. So in this case, I would say I have 1 whole and 3 more pieces out of 4. Okay, so you'll notice the bottom number is the same because I haven't changed the amount that make a whole. But an improper fraction has the top number as bigger than the bottom number, and a mixed number writes the whole number out front and then a regular fraction beside it. So when we are solving problems with fractions, we might want to go between these. We might want to take the mixed number and write it as an improper fraction in order to do our calculation. And then we'd want to put it as a mixed number or back into a mixed number at the end. So let's look at how we go between them. Now keep in mind, when I'm converting between an improper fraction and a mixed number, I'm not changing the amount of slices or pizza that I have. Okay, I'm not changing the amount. I'm just writing it in a different way. So in this case, I have 4 pieces, and it takes 3 pieces to make a whole, which means I have 1 whole piece and 1 out of 3. Okay, so I'm looking at how many wholes, how many parts. I have 1 whole and 1 more out of 3. Okay. So if I have this one, I have 5 pieces and it takes 2 to make a whole. If I'm writing this as a mixed number, I would say it's 2 wholes and 1 out of 2. Now, if we don't want to use an image, if we're not wanting to draw this out in order to do this conversion, what I'm thinking about is how many times does 3 go into 7? How many wholes fit into this, and how many pieces are left over? 3 can get to 6 by timesing by 2, right? 2 3s get us to 6, which leaves us 1 piece left over. So I'm thinking, how many times can the denominator go into the numerator fully, and how much is left over? In this case, it can go in 2 whole times, with 1 out of 3 left over. Again, remember the bottom number stays the same because I'm not changing the pieces. Just a note, if when you're doing this, you end up with no remainder, so 5 goes into 10 fully 2 times with nothing left over, you can just leave it as 2, as the whole number. You're not going to write it as 2 and 0 over 5. You would just write it as 2. So I want you to try these ones. You're going to convert them from the improper fraction to a mixed number. Pause the video, try them out, and start it up again when you're ready. Okay, so 4 goes into 23 5 times with 3 left over. So I'm going to write it as 5 and 3 over 4. 8 goes into 59 7 times with 3 left over. And 5 goes into 102 20 times with 2 left over. So how do we go back? If I have a mixed number, how do I write it as an improper fraction? Well, what we're asking ourselves is how many pieces do I have in total? So to do that, we're going to multiply the denominator by the whole number to figure out how many pieces I have out of the wholes. So in this case, 4. So I have 4 pieces that are in wholes, plus the 1 left over. So you're going to do 2 times 2 plus 1. That number goes on the top, and then the denominator is the same. Okay, so for this one, I'm going to do 2 times 4 plus 1. Gets me to 9 over 2. And here I'm going to do 3 times 3 plus 1, which gets me to 10 over 3. So I want you to try these 3, convert the mixed numbers to improper fractions, pause the video, and start it up again when you're ready. So for our first one, we're going to do 4 times 3 plus 3, and I get 15 over 4. For number 2, we do 6 times 5 plus 5, and I get 35 over 6. And then I do 3 times 10 plus 1, and I get 31 over 3. So all together, I want you to think about how you've done. Can you find equivalent fractions and common denominators? Can you simplify fractions? And can you convert between mixed numbers and improper fractions? If you are the sad face, you're really not sure what's going on, you're having trouble, you're going to ask your teacher or look for more resources to help you understand. If you're the thoughtful face, you're going to do some more practice questions. And if you're the happy face, you understand you're good with this, then you're going to, again, I would try just a few just to make sure it's locked in your brain, and then you're going on to the next topic.